Yes, my name is John Elfie. I'm an applications engineer here at HeatPipe Technology. Again, thank you for joining me today. This webinar is going to be mainly focused on Select Plus and how to select wraparounds to optimize for dehumidification. I'll go through some examples and kind of get into wraparounds a little bit, just the design of wraparounds. If you haven't already done so, I would recommend to register for Select Plus. It's actually not going to be critical that you have it today. I'm going to be going through some basic examples at a fairly slow pace. And also this webinar is going to be available on our website at heatpipe.com. So if you miss anything or have any questions, you can always go back and watch the webinar or whatever part you want to see. But if you do need to register, it's very easy to do. Either go to heatpipeselect.com, which is the website shown on the bottom there, or heatpipe.com. And once you submit the information that we require, within 5 to 10 minutes you'll get an email to set up a password. And then basically after that you're pretty much ready to go. But again, if you don't have it today, that's okay. All right, moving along. A little overview. I'll talk about what is an optimized DHP. For those of you who are not familiar, it's a fairly new product for us, maybe around, I want to say, a year and a half that we've had it. And it is a slight variation to our standard wraparound that some of you might be familiar with. And I'll also get into, obviously, some selection examples of wraparounds in Select Plus. Then I'll do a quick savings analysis using temperature bins. And then I'll wrap it up with some helpful tips and shortcuts, just to speed things along as you're working through Select Plus on selections. All right, one thing I forgot to mention is we are UL certified, ETL listed, and this is on all of our products, including wraparounds, energy recovery, split passives. Everything that we offer is UL certified, so you will see that seal of, or the stamp of UL certification on all of our products. All right, really quick, a little HeatPipe refresher. If you take a look at this graphic, HeatPipe is basically an enclosed pipe or tube, if you will, that as you apply heat on one side, the refrigerant uses basically the latent heat of vaporization and condensation to move energy back and forth. So if you take a look at this graphic, if you were to apply heat on one side, the refrigerant would absorb that heat, vaporize. It would move over to the cold side where it would give off the heat, condense, and then make its loop back around. And it's a continuous cycle as long as you have delta T or you're applying heat to one side, the refrigerant is going to move that heat over to the cold side. Now, if you consider the heat side, the evaporator side, in our case, that is, when we're speaking in terms of wraparounds, the pre-cool side, absorbing the heat, cooling down the air. And on the right-hand side, where you're giving off heat, the condenser side, well, in our terminology, that's going to be the reheat side. So we're giving off heat to the air, leaving a cooling coil, and that's where the reheat effect takes place. So the old approach, the typical approach of cooling and reheating, typically if you don't have a wraparound, you're going to oversize the cooling coil to hit a dew point, if you will, to remove enough moisture from the air. And after that cooling coil, the temperature is going to be a little too cold, too uncomfortable as far as RH is concerned, so you're going to reheat. And in some cases back in the old days, which some of you might be familiar with, is they used to have obviously electric coils for reheating. And that's obviously a no-no nowadays. Typically you're going to see either gas or hot water reheat. You obviously do need to reheat, you do want to reheat for some applications, according to ASHRAE, and also too to have a better environment inside the space. So this is the old way of kind of doing things. If you add a heat pipe, there's a few advantages. Now in this case, what we're seeing, just kind of work through this diagram, is we have the pre-cool section, we have hot air entering that pre-cool section, the refrigerant is absorbing the heat, it's boiling, and that vapor is traveling to the downstream side, which is the reheat side. So whatever heat we absorb, again, the pre-cool, we're going to transfer over to the reheat. Now in this case, the pre-cool, if let's say you're talking about a DX system, you have the advantage of either downsizing your DX system, going with the lower tonnage, or if you have fixed capacity, if you don't have the ability to to increase your tonnage for whatever reason, cost, space, whatever issue there is of not being able to go up to a certain tonnage, well then the pre-cool, what it's going to do is it's going to remove some of the sensible load, and that way your cooling coil can actually do more of the work as far as latent heat is concerned. So in this example, we're seeing 80 degrees, pre-cooling down to 72, which is what your cooling coil is seeing, and then from there it's doing the rest of the work to 50 degrees. And obviously, again, the energy we capture in the pre-cool, we're going to move over to the reheat side. And the advantage of the reheat, obviously the biggest impact is going to be energy savings. Even when you use gas or hot water, there can be, depending on the location, significant energy costs with that. I've seen instances where either we completely replace gas or hot water reheat, and I've also seen scenarios where we're going to do the majority of the work in certain climates, if you will, or hours during the year where we don't do enough to reheat. Well then, if you have any additional reheat downstream, it can do the rest of the work, but there's still energy savings there. And that's the biggest effect of the reheat. So moving along. So the wraparound. This is the new, what we call tilted wraparound or optimized. The way we refer to it a lot of times is the DHP-Z, Z standing for optimized. And again, it's a fairly new product. If you take a look at this graphic here, we have the right-hand side, that's the pre-cool, and left-hand side, that's the reheat. Now what we've done is we actually implemented a fixed angle to the tubes. The outer casing itself, it's still square, but if you look at the fin pack, it's actually, you can see that, that slight angle. And what this does is that angle, it actually helps the refrigerant flow because of gravity. So in some cases, when you compare it to standard U-frame with horizontal tubes, you can see anywhere from 10 to 20% improved in effectiveness. So instead of needing a 4-row, maybe you might get away with a 3-row, or maybe even with a 2-row, depending on temperatures and other variables. One thing to consider is when you do go with the tilted unit or DHP-Z, there are going to be varying top and bottom flanges. You can kind of see them here. If you can see my mouse, the flanges in this case, they're going to slope up from the pre-cool. So you're going to have your minimum flange here, and it's going to go all the way around, and you're going to have your higher flange on the reheat side. So that's because obviously we have that angle, and the longer the fin length you have, the greater or the taller this flange is going to be, the maximum flange. So when you're designing something, it's I guess something to take into consideration. Really, when you have coils or cooling coil that's in close proximity to our either pre-cool or reheat, we've tried to do our best to design the tilted unit to where even if you have a cooling coil close to one of our coils, the airflow isn't really impacted. So we have made some work in designing it a certain way to where it doesn't impact airflow because of the larger flanges. So I think as far as that's concerned, just a quick little intro to wraparounds, that's pretty much it. What I'm going to do now is get into some selection examples, and we're going to get into Select Plus. If you guys haven't already done so, you can go ahead and follow along with me. Bear with me here. All right. So this is the login screen. I'm going to go over some of the basics with Select Plus, and if you miss anything, again, you can always come back to this. So I'm going to sign in here. And after you sign in, this is going to be your first page that you see. This is your dashboard. A few little things that you can kind of look through on your by yourselves here. The page that is going to take you to the list of your projects. That's going to be this little tab up top. It's called My Projects. If you click that, it's going to take you to a project list. I only have one in this case. I just created this account. But you would see, if you have 100 projects, you're going to see the list of projects here. And you can always get back into something to make changes. To add a new project, what we're going to do in this case is we're going to add here in this box, new project name. Let's do DHP-Z webinar. That's what I'm going to do at least. Then click Add New Project. And it's going to take you to a project information screen. This screen's pretty cool because you can list any information that you have in the project. So if you forget anything or need to remind yourself, you can always come back here to this project screen or project info screen, and it's here for you. You can also change your display units. You have project type and other valuable information that you can input. Here on the right-hand side, there's a defaults section. I actually wouldn't recommend to touch this section because what happens is it's not only a default, well, I guess it's a default for any other project or new project that you create. So if you were to have a specific project where you have actual elevation, on the very top of a very tall building, well, if you change your settings here, it's going to carry over to each project, and you might not realize that. So what I would recommend is actually when you get into the input screen of each specific item that you're selecting, you can change this there, which you're going to see in a little bit. All right, so if everything looks good, you click Update, which is sort of here towards the center of the screen. Hope you guys can see my mouse. And there you go. There's a new project that we created. So to get into the selection itself, there's a couple little icons here. One is the schedule icon. That's what we're going to be clicking. And then next to it is submittals icon. If you click that, it's going to take you to a page where you can output a submittal. But obviously, you have to have done selections in order for that to work. So we're going to click Schedule, which is that little icon there that I mentioned. I hope you guys can see this. There you go. This is your project schedule screen. And up top, you want to make sure you're selecting the right product. We obviously have heat recovery or wraparound. We're going to select wraparound. The quantity, I wouldn't really mess around with that too much. You can change the quantity of each line item if you have more than one unit in the actual selection, which you'll see here in a little bit. But once you click the product type, you want to make sure to click Add New Line. And that's going to add a line item to your project. So you can obviously keep adding new line items if you have more units. I'll show you a little shortcut later on for doing that. So some of these icons, really quick, we have the Select Item. It's going to be your main selection icon. Then you have View Reports, and that's to output individual reports for each item. You can do bin analysis, performance, drawings, all that good stuff. And then next to that, you have submittals included, a little toggle switch, which I'll get into a little bit later. But let's get into the selection. And again, you want to click this first icon. It's a green piece of paper. I don't know why it looks like that, but it's just the way it is. And with this screen, this is your main input screen. I would just recommend starting on top, working your way across, and then down. You have a quantity. You can update your quantity. You can input whatever tag you want. Product line, we have two product lines, U-frame. U-frame is units that are installed by typically manufacturers, by others, and they're basically ready to install modules. We ship them out with fully charged, and if someone's building their air handler or whatever unit they're building, they're going to drop it around their cooling coil, flash everything off, and then pretty much just it's ready to go. Then we also have the option of factory installed. That's where somebody can ship us a cooling coil section with the cooling coil already installed, and we're going to install our heat pipe. And after everything's done, then we're going to ship out that section to wherever's needed. So moving along here in the middle column, we have a couple of design options. We have tubes. Actually, tubes we only offer 1/2 inch. Thin material, either copper or aluminum. Refrigerant, we have two options, 134 or 410A. And then coating, we have electrofin or Harrisite. And then here, moving along to the right, this is where you can actually change your air type, either standard or actual, and the elevation. I don't know if you guys can see, but the controllable option, we do offer control valves. It's actually, you can't select it, it's grayed out, and the reason why is because we don't offer control valves for tilted units. It's just because of the design doesn't really make it feasible, too many valves. But if you do need control valves, then you actually have to switch the product type from tilted to level. And you can see there the option for selecting controls is actually you have that option now. So we're going to switch it back to tilted. You guys want to do that with me if you're following along. And towards the bottom of the page, you start getting into the physical dimensions, airflows, temperatures, all that good stuff. I'm going to move down here to the airflow and temperatures. We have a few options. We can either do mixed air. Doesn't really change anything other than the category, 100% outside air. And we actually have a mixed air calculator built in. So if you have your ratios and your temperatures, once you input these numbers here and then go to the calculate button and click it, which is over here on the right-hand side, it's going to calculate your mixed air temperature for you on the next screen. But to keep things simple, let's do 100% outside air. And I've already had some examples in mind. First example, I kind of went large scale, 15,000 CFM unit. So I'm going to input in 15,000 CFMs. And I'm going to do 100% outside air temperature. And the values that I selected, which I believe are Tampa design conditions, and if not, I'm slightly off. 92 degrees dry bulb and 76 degrees wet bulb. And going back up top now, sorry for jumping around a little bit. I just wanted to show you the this mixture calculator really, but jumping back into the actual dimensions, I sized the unit, this example, at 400 feet per minute, which is typically what we see, or I guess maybe the sweet spot for wraparounds, best bang for your buck. Fin height, again, size of 400 feet per minute. I went with 60 by 90. And let's start with one row, just to see where what that gets us. All right, so now moving along down here. Another important input is a span. The 12 inches is going to be the default, but what I would highly recommend is you be as accurate as possible on your span. There have been issues where somebody just leaves it the default, and as the project moves along, they want something much larger span, and there could be an issue because we actually have max circuit length, if you will, the heat pipe, which can affect span and can actually affect fin length. So the span is it's dependent really on the fin length. So the longer fin length you have, the less span we can do, and there's going to be a max. So it would be best to be as accurate as possible up front. So down the line, if you need something, you know, that's 90 inches span and it's already pretty far into the project, well, you come back here and you realize that that's outside of what we can do, then obviously you got to deal with that moving along. All right, so next is your cooling coil leaving air temperatures or conditions. And we have two options. We can either input temperatures, dew points that you're looking for, and we actually do fixed capacity. So fixed capacity is really going to apply, I think for the most part, with DX systems. And I'm going to start with the fixed capacity, and then the next example we'll do temperature inputs, because the fixed capacity, when you get into the situation where, again, you have a DX system, and you have a certain tonnage, you don't want to go more than that tonnage because of cost. Well, again, this is the beauty of the wraparound, and specifically the pre-cool, is we're going to actually do some of that load or that work for the DX system. So let's take a quick example of fixed capacity. Let's say we're doing a large unit again, 75 tons. So that's going to be about 900,000 BTUs. That's 75 tons. And again, remember, we're selecting one row, and we're at 12 fins per inch. So if we click calculate, that's a 75-ton fixed capacity. See, we're doing 92 to 86, so that's that sensible load that we're removing. From there, that cooling coil is doing the rest of the work to 58, which is pretty high, typically not a temperature that you see. And then from there, whatever energy we capture in the pre-cool, we're moving down to provide free reheat. So we're going from 58 to 64 in this example. Some other important, I guess, values here. You have your effectiveness. You guys can see that. Got your pressure drop. This is per side, so the pre-cool, I guess 0.09 inches on the pre-cool and then 0.09 inches on the reheat. So combined, I was going to have 0.18 inches on both pre-cool and reheat. And what I mentioned before, 58 is typically something you don't see. So if we go back, we want to get a little more, a lower dew point, if you will. If we go back and actually do a reselect, which is right next to this continue button here, do a reselect. Go back here to this screen, and let's go up to, let's say 3 rows. It's still 12 fins per inch. Let's click calculate. And now we're around 55 degrees. So you can see we're pre-cooling from 92 to 78, from 78 to 54. So in this instance, we're helping dehumidify the air by doing some of the work, the sensible load, so that the cooling coil can do some latent heat removal and get to a lower dew point, so you can grab more moisture out of the air. And then from there, we're heating up to 68 degrees. Might be a little high, around 58% RH. Again, this is just about tweaking performance, getting it to the point that you want. So let's go back again. Let's do Reselect. So let's say we have, again, fixed capacity. Let's go even larger. Let's do an 85-ton unit. So 85-ton, you're looking at a little over 1 million BTUs, which, luckily enough, I've already done the math. Configure. So that's an 85-ton fixed capacity cooling coil. Now we're at 3 rows, 12 fins per inch. Click Calculate. Oh, gave me an error. So that's actually a typo on my part. I think I need another 0. There we go. Calculate. And there you go. Looks like we're doing 15 degrees pre-cooling. Cooling coil's doing the rest of the work. Dew point down to 51, a little over 51, and then we're reheating up to 66 degrees. So again, you can see that that's fixed capacity. So your cooling coil is doing that 85-ton capacity. Let's tweak this. Let's get somewhere between 52, 53, which is pretty common temperature or dew point. Let's reselect, and let's go down to 2 rows. If you guys are following along here, and calculate. Pretty close to 53. If we want to play with fins per inch, we can do so. Again, reselect. Go 13 fins per inch. It's, 13 fins per inch, some people might not like for cleaning purposes, but, if you get to the point where you have to go up in fins per inch to not have to go up a number of rows, then that's something you can do. So let's go with 13 fins per inch, and we're a little less than 53. Let's stick with that. So 52 degree dew point. You can see that we're doing about 195,000 CFM. So roughly, let's see what that is. Roughly 16 tons of pre-cooling that we're doing already, and then the cooling coil again is doing 85 tons. So if we take a look at this psychometrically, and by the way, we actually have a psychometric chart here on the right-hand side. If you take a look at this little button, click that. It's a psychometric chart that you can actually output in a PDF later on. But what I did for this example is, taking this exact example here, is I created my own psych charts, just a couple of PDFs. Now, if we take in that example, only a cooling coil, and again, we have a fixed capacity, 85 tons. We're seeing design temperatures of 92, 76. At that capacity, we're getting down to a dew point of around 96.5 degrees. And again, this is without a wraparound. So your humidity ratio, you're probably looking at around 68 grains of moisture per pound of dry air. And again, this is no wraparound. Now, if we add a wraparound to this, the example we just saw, this is where you see that curve start to shift. Now, before we were around 56.5 degrees dew point. Now, if you can see here, we're all the way down to 52.5, which is the example that we saw. And the humidity ratio is 58, so we're removing more moisture out of the air. And this is, again, the beauty of the pre-cool, but not only do we have the pre-cool, then we also have the reheat effect. So even more added advantage with energy savings as far as reheat is concerned. So again, you can see that shift in the psych chart with the addition of the wraparound. So I hope that kind of makes sense. Again, if you guys have any questions, feel free to type them into the chat screen, and I'll get to them at the end of the webinar. All right, so moving along, I'll get into economic analysis here in a little bit. Let's click Continue. We'll do another quick example. This is a drawing screen. A couple of things to point out. Again, how I mentioned before, if you take a look, you can see that slope here on the this entering side, and we have minimum flanges, which is 3/4 of an inch. And all the way on the flip side, when you see your maximum flange, it's going to go. If you guys follow along with me, there's a little table here which shows the varying flanges depending on where you're at in the heat pipe. But the minimum is going to be at 3/4 of an inch, and the maximum is going to be a little less than 4 inches. And again, this is based on how long or how big of a fin length you have. The longer the fin length, the higher that, or the larger that that flange is going to be. So if you want to make it shorter and taller, that's probably better as far as flange dimensions are concerned. But on top of that, the longer you go with a heat pipe, the more impact you have on performance because it's a passive device. So you can play around with some dimensions and see that a shorter fin length, but same face area, is going to give you better performance than a longer fin length with the same face area. So one thing I actually forgot to mention to you guys, actually before I do that, let me go through a little more on the screen. So we have the drawing, we have the description here, all important dimensions that we have to look out for. The frame, this is actually where you switch it. You can either do galvanized or stainless steel. When you select something, it's going to actually update the description, you can see here. Number of sections, we can break this up, that fin height, into, in this case, 1 to 3 sections. If we do two sections, you can see that the fin height is split up into 2 sections. We actually have a max fin height per section of 75 inches. So once you go above that, Select Plus is going to automatically break it down into more sections. All right, I think that's pretty much it for this screen. Again, I recommend going in, kind of playing with some of this stuff. There's a lot more options you can do. This is just more of a basic tutorial. So one thing I want to show you, let's click back. We're going to go back to the results. And then let's go to Reselect. I wanted to give you an idea of what the performance difference is between a standard, a horizontal, and a tilted. So the tilted, to remind you guys, if we look at, let's say, reheat, we're reheating up to 64 degrees, or almost 65 degrees, and we're looking at effectiveness of around 30%. I'll go to level, where effectiveness went down to around 25% because we don't have gravity to help us out. And reheat, we're looking at around 63.5 degrees. Now, again, before we had an effectiveness of a little less than 30%. So if you were to calculate that, that's around a 15% increase from going to a horizontal standard U-frame to an optimized. So that's the advantage, in this case, of the optimized wraparound. All right, I think that's it for this example. Let's move on to another quick example here. Well, that looks good. What I did, by the way, there, guys, sorry if I went too quick, just click Save and Close, and it takes me back to this project schedule screen. All right, let's do another quick one. This is another wraparound. Let's do Add New Line. There you go. We have a new blank line item. Let's go back into the selection. And in this case, we're going to keep everything the same up here. Nothing's really changing. Actually, you know what? Let's do coding, just so you can see that description down the road in the drawing. I'm going to move down to, let's do mixed air. We're going to do a smaller system this time, 7,500 CFMs. And let's do 80 degrees dry bulb and 70 degrees wet bulb. Now, I sized again at around 400 feet per minute. So my dimensions that I went was 45 by 60. And 2 rows, keep that the same. Span, let's go 36, just so you see that change in the drawing down the road. And this time let's do temperatures. So let's say we're trying to get to, I don't know, 54 degrees. So 54 dry bulb, and let's do 53.8 wet bulb. That's the temperature that we want our cooling coil to leave. If we hit calculate. So if you're doing a cooling coil selection, then you would input in this temperature to give you, I guess, your parameters of your cooling coil, GPM, either glycol mix. But again, we're having that advantage of doing some of that pre-cooling. So even with the chill water coil, where you don't have the advantage of downsizing, you're going to likely use or lower your GPM, drop the temperature that's coming into your, I guess, your water supply, which obviously has energy savings associated with it. So you can see here, and then reheating from 54 to 61 degrees. 75% RH, that's a little on the high side. So if we do a reselect, let's jump up all the way to 4 rows and 12 fins per inch. Calculate. And there you go. We're at 65% RH, 65 degree leaving reheat. We're doing about 94,000, a little less than 95,000 BTUs of pre-cooling and reheating, and your cooling coil is doing around 293,000 BTUs. So whatever, it's sort of an iterative process when you're doing a cooling coil selection. Whatever your leaving temperature is from here, you're going to input it into your cooling coil entering temperature to get, again, your parameters. All right, so that's it for this. If we move along here, click continue. Again, this is your drawing screen. Some of the options that we changed were electrofin, which if you guys look at the coding description here, we have electrofin shown. Our span we changed to 36 inches. So we show each coil width, which for 4-row in this case is 5.5 inches. And that's obviously going to be the same for the pre-cool reheat, whatever this is. And we also have an important dimension here, which is our crossover tube depth. This is what we're going to need, the space you're going to need to account for from the return bends of the cooling coil to the wall of your air handler. And again, we have flange dimensions and overall dimensions, overall heights and lengths here on the bottom. Let me show you guys one other very important thing when it comes to wraparounds is the handing. The wraparounds are only going to work in whatever handing you specify. So the way we do it is air hitting you in the back of the head, and you're facing the pre-cool, whatever side our connecting tubes are at, that's what side, that's what handing is for the heat pipe. So for example, let me choose an option. Let's just do a right-handed heat pipe. You can see the drawing's going to update. See the airflow here in this plan view, pre-cool, air hitting us in the back of the head. We're facing the pre-cool. The connecting tubes are on the right-hand side, so that's a right-handed heat pipe. And it's only going to work in this, this scenario. You can't flip the heat pipe to account for a different airflow direction. All right, so I think that's pretty much it for this and for the selection examples. If that was too quick, I apologize. There's definitely a lot of stuff to cover. I guess something else that I should mention really quick is we do have a YouTube channel out there. We have several 2 to 3 minute videos that you can watch, and it covers basically all of our products and different sections of the selection process. So if you want to focus on bin analysis, then we have a little video that's geared towards that. Speaking of bin analysis, let's go ahead and do a bin analysis or economic savings analysis. And we're going to get back into the larger system, the 15,000 CFF system, again by clicking the select item. And if you want to go to the economic analysis, you're going to have to go through calculation, so hit calculate. Down there at the bottom right is your results screen. If you guys remember, there's a psychometric chart. And we also right below it, that's where we have our economic analysis. So if everyone's following along, go ahead and click economic analysis. And that's going to take you to this screen. So layout's a little, I guess, a little different for this. What you want to do is follow the steps, which are very, very big, just kidding, small red letters here, step 1, step 2, step 3, and then all the way to the right, for some reason, we have step 4. So I'm sure we'll be working on to kind of change this layout, make it a little more intuitive. But let's start with step 1. Let's choose a city. I'm going to go crazy. I'm going to do Tampa, Florida. So let's pick a state, past Florida. Here we go, Florida. And find your city. Tampa International Airport. And we're going to click Apply. All right, so the next step is step 2. That's the runtime hours, depending on the application. Offices, obviously you might see 8 to 5, year-round schools, you know, maybe 6 to 3, 8 months out of the year. So that can vary. But for this case, we're just going to leave it 24/7. and 12 months out of the year, or the entire year. And step 3, we're going to do load bin data. So you can see there that the bin data was populated with temperatures, outside air temperatures. What wasn't populated was the cooling coil temperatures, the leaving dry bulb and leaving wet bulb of the cooling coil, which was from your initial selection, and your CFMs. That wasn't populated all the way down to each bin. But the way we do that is actually step 4, which is over here. It's called duplicate row. If you click that, that's going to copy over those values down below. If you want to do by hand, that's fine. It's just obviously it's going to take a while. If you have, maybe if your temperatures vary or CFMs, you can go ahead and do that. If all that looks good, then back here towards the top we have calculate economic analysis. So we'll click that. And these are your results in a sort of a small picture here, results. What we have are some inputs as far as the reheat type and rate. So electric, you're just going to input your electric rate, and what this is going to do is it's going to be for static penalty. One of the things to consider with wraparound is when you're adding wraparound, you're adding basically a coil. So there's going to be a slight static penalty associated with adding wraparound. And you also have the option to input either hot water in the cost or gas and fuel. Let's say hot water, and we're going to keep it at default of a little over $1 a therm, maybe a little bit on the high side, but we'll just keep it here for now. Some other inputs, we have EER, we have motor efficiency, fan efficiency, burner efficiency. The burner is obviously going to be dependent on the gas fuel reheat, if that's what it is that you're selecting as a reheat type. But just to give you guys a quick picture, we'll just keep those values here. And if we go over to the right-hand side and click Calculate, this is a quick view of what your savings are. So basically using this EER and electric rate for static and pre-cool savings and the reheat type, obviously for reheat savings, then you can see savings broken down and penalty costs, and you can actually see your overall net savings per year. So typically with heat pipes, you're probably going to see a little over 2-year payback. So once that's paid off, you're going to keep getting that pre-cool and reheat basically for free. So that's pretty much it as far as the bin analysis is concerned. Again, we do have a YouTube video. If you guys want to check that out, it's around 3 minutes, so it gets a little more in depth. All right, just kind of wrapping up here. Really just, I'll show you guys some quick tips and some shortcuts. One of the things that I mentioned is if you ever want to output reports, you can do that either 2 ways. If you want to do individual reports, we have a little icon here that I mentioned before. It's in the center, looks like a little graph chart. You click that, it'll give you what it is that you want to output. So you want design and drawings, click report. And let's wait here a second, there we go. That's what you're going to see. And up top, if you want to, you can actually save this as a PDF or download it as a PDF. There's a little floppy disk, and you can download, you can choose to save it as a PDF. So that way you can share it with anyone, an engineer or anyone else that you have that you might be working with. What I like to do actually is when you have multiple sections or multiple items, so you have 10 for this project, is you can actually output one document and select which line items you want to include in that document. And that's done by this little submittal included toggle switch. So in this case, if I select both to yes, then both are going to be included in that submittal document. So say we only want to do the top, it's a 15,000 CFM unit. We're going to click the other one, we're going to click no, and then we're going to go up here towards the top and click submittals. I hope you guys can see that. We have project info, users, submittals. We click that, and then similar as before with the reports, we're going to select what it is that we want to output, and let's do design, bin, and that's all we want. We don't want anything else. And we save the PDF. It's going to download a PDF. Depending on how many selections you have or line items, it can take a little while to actually download. This one hopefully won't keep me waiting too long, and you can see here it's download. and here are the results. So you can see that we have the first line item. There's an order code. Moving down, these are the results. 15,000 CFM unit. Keep moving down. This is the bin analysis. It's broken down into each bin, and also we list. We got the pre-cool savings, or reheat savings, penalty, a fan penalty, and you have your overall net savings of the heat pipe. So that's documents. If you want to output performance, a little shortcut. Let's see what. I think I'll wrap it up with this last tip, guys, just because getting a little tight on time. If you have an instance where you have, let's say, a different project with similar units, instead of having to create a new line item, a new blank line item, say you already did a project that has similar units and you want to copy those line items to a new project, well, what you can do is create a new project, which is what we did before. And when you get into your old projects that you want to select your line items from, well, you can select whatever items you want. Let's say we have these two original ones that we did. Just click that check mark, and then if you move down to the bottom, there's a copy to button. Before you click that, what you want to do is move over to the right. There's a drop down, and it's going to give you a list of the projects that you've created. So if you have the other project you created, select that project, click copy to, and it's going to copy these line items that we just selected into that new project. And you can go into it by clicking My Projects. This is the one that I created before. It was Test 1. Open it up. And I already did some selections for this example, but these are the two that we actually copied over, these two here. So that can definitely save time, so you don't have to start from scratch. And you can actually do the same thing within the same project. Instead of clicking the drop-down, select whatever line items you want, and then just click Copy To, and it'll copy them down to this same project. So I think that's pretty much it. Again, sorry if I went a little too quick. What I'm going to do now is I'm going to see if anyone has any questions. If you guys bear with me for 1 second.